Hello everyone. So today also we are going to continue with our template for the real-time strategy unit-based game that we are going to work on. So today we will be working on WSAD movements for our top-down controller using C++. So in our project, at the end, you will be able to move around the world using this WSAD buttons. So this is the second episode still. So yeah, let's see how to do this. So here we will set up enhanced input for our player controller and also for our pawn, and we do a binding to the input action for our pawn class that we implemented, and we will be using C++ for that. Okay, so before we get started, let me remind you that you can download the project files of this project and all other thousands of projects I have done in my channel from the Patreon page. Link would be in the description below. And also, in addition to this C++ series, I have done this strategy controller. This was here I was using blueprints, but if you are interested, feel free to check out this series as well. This is also somewhat similar to this series that we are working on, but here we are focusing on more unit-based combat for a strategy game. But this was only focused mostly on like interactions and controller aspects of a strategy game, but this is in C++. So yeah, feel free to check that out if you're interested. And now let's get back to today's tutorial. Right, so this is what we implemented so far. Now we have our controller pawn, but it doesn't really do anything as of now. It's just there. It has a let me open that too. It has this spring arm component, camera component, and capsule component like this. So the next step is add in a controller so that I can use some movement input to this pawn, and that should be the next step. So here let's create a new C++ class using the type player controller. Next, I'll add it to top-down utilities, and I'll call it down player controller. That seems like a suitable name. Create. Okay. Reload. Here we have the top-down player controller C++ file, and here is the header file. Now, first thing is we need to add a constructor here, a top-down and so here we need to add we need to override the setup input component function so that we can add our desired input mapping context into this controller. So sure, wait, a input. Right. Okay. Now let's implement these functions. First, this one, create definition. Now here, only thing I would need is be show mouse cursor. Oh. We'll need this later on when we implement point and click kind of movements when we have character selections. So, and let's implement this too. Oh, one more thing here, don't forget to, no, so it's not needed here. Okay, let's implement this. Okay, now here, in order to register the input mapping context, first we need a reference. We need a reference to some input mapping context. So let's go back here, and on the public, I'll add a U property like this. I'll set it to edit anywhere, maybe not necessary. Edit defaults, let's just say. And so this, we get an error. So let's forward define U mapping context class, U input mapping context. Okay, now let's go here. So we need to add that input mapping context into our controller. To do that, first, before anything, I'll call super function. And if we don't have a valid reference to the to this input mapping context, if we haven't assigned a value to this, we should not try to add it to our controller, otherwise we will have an error. So to avoid that, let's do this. Default context. If we have a null reference here, just simply return this function. If not, we can continue. Now here we need to get the enhanced input local player subsystem. So we can do that like this. U enhanced input local subsystem. I don't get the suggestion here. Okay, in order to be able to use that, we need to add enhanced input module. Let me just check, and I don't think it is added by default. Yeah. Oh, we already have it. Okay. So this needs to be here, otherwise you can't add anything in that module. Yeah, this is the header. And since we are using this U input mapping context, we would need this also. Why am I getting this error? Oh, yeah, I was checking the build file of the project. That's not what I need. I need to check in here, drop down utilities plugin build.cs. But here we don't have enhanced input, so yeah, that should be the reason. So I'll copy it to the, yeah, I'll add it to this private dependency module names. Okay, now this should work. Let me compile and see. Yeah, it is working. Okay, right, but still this is not, this shows as an error, but it will be fine if I just close this and refresh the project. Okay, now the error is gone. Alright, now we can do this. me see here. Let's call it subsystem. I'm not using this anywhere else, so only right here. Local layer subsystem. Next input local layer subsystem. Okay, now if this term is valid, then only we can add subsystem and mapping context default input mapping context priority 0. All right, just to make sure that things are working, I'll add a UA log as well. Type display is enough. Input mapping context. All right, let's compile here. Okay, now let's create a blueprint class based on this player controller. Edit under plugins, step down utilities, blueprints, game framework, BP top down player controller, and create. Okay, now here we have default input mapping context variable. So we don't have anything in the project, so let's just create one. Now I'll first create one input action for movement. Let's call it IA move. I'll make it axis 2D because this is going to be used for WSAD movement, which is an axis. And then here I'll add a mapping context. IMC top down. Let's add one mapping. Here we only have IM move. Let's add 4 keys. 1, 2, 3. Okay, and first one is W. And this is the forward movement. So I think I'll have to add the whistle here, so it gets the Y value. And this also need to get 2 modifiers because this is backward. Whistle and then negate because S is going backward. And the other thing is A, which is going to left. So modifier to negate to get minus X, and this is T. We don't need anything here. By default, we will get positive X. If I'm wrong, we can come back here and change. Right, Now we have a mapping context, which is this one, and I can assign it to my controller here. Okay, all right. So in order to use this player controller, I need a game mode, but right now we only have this default game mode and game mode base. So let's create a game mode class as well. Game mode base, drop down utilities, drop down game mode base, create. So I don't really want to make any changes in the C++ code. I'll simply create a blueprint based on this because but I just want to keep the C++ base as well, just in case I'm gonna have to do some things in C++ in future. So that's why I want to keep it as a C++ parent and then create a blueprint based on that. But if you just create this as a plain blueprint, you can later on reparent it as well. That will also work. Right, now here game player controller. I can add top-down player controller. And default pawn, add PP controller pawn. Okay, now here we can use top-down PP top-down game mode base. Okay, now we have the player controller. Let's just see. When context added, it did show up. Why? Yeah, I should have added PP top-down player controller. Okay, now here you get input mapping context added. Alright, now we have a mapping context. Next step is adding some movement to the character. So in order to add movement input, we need to do that in C++ level. We have to specifically add to a binding. So to do that, here first let's go to the pawn. Here I'll add this u input action, move action. So I'll define this class also here. Right now this would be, if I compile this, compile here, now if I go to the controller form, and the input, where's the input? We should get the move action somewhere. Oh, here, move action. Now here I can assign IMO. If you don't assign it, you should do a null check before trying to bind it. Okay, now in here, before I try to do anything with the input action here, let me add the header file, and then we can do the input binding in the setup input action, setup player input component function, which is already there in pawn classes. So we can override it here. Set up player input component. This is the function. Now, oh, I already added it here. Okay, right. So let's go into that. Already did this yesterday. Okay, now before I add the binding, I need to check if we get a valid 𝐿 input component as this player input component. So to do that, here you I don't get the suggestion because I don't have the header file. So yeah, input component was, so we need to cast this player input component into a enhanced input component. So cast, sorry, you input component pass player input component. Okay, so if this step k is passed, then we can do the binding. So find move function. This is how you do it. Enhanced input component, find action. First we need to give the input action, which is move. Did I call it move? Move action. Okay. Oh, I forgot. Here we need a function as well. So first we need to pass the input action and then trigger event. We trigger event triggered, and then the function that we need to bind this move action into. So it should be headed like this. Adapted f input move. I'll call it move, and we need to pass this value, f input action value. So this also need to be added. This is a structure actually. If you click here, you see it is in the enhanced input library, and you also use the f, so it is a structure. So I'll forward define it. Struct f input action value. Then here, oh, I have already added this input action value. Okay, so oh, we have missed something. All right, in the middle we need a reference to this, which is here 𝐿 reference. Okay, now it's all good. Right, now let's implement this. So here we can define what should we do when we get a movement input. But before we do that, if you quickly want to test if the input action binding is working, here let's first build it. then controller pawn, move and the print, so you can put the value. This is just to see if the binding is working. See, when I press D, I get x1, y0, A, x minus 1, y0, S, x0, y minus 1, W, x0, y1. So it is working, and I will remove this because I want to do this in C++ side. So here, first we can get the input value. So const f vector 2d want input equals value, which is this value, and get that value as vector 2d. Okay. Because we are binding this to a access 2D, so the value would be in a f vector 2D format. Right. Now, if we have a valid controller, this is already there by default in the pawn class, so we don't need to define this. So if we have a valid controller, then we can get the controller rotation and determine forward direction and right direction. But before that, let's just add some moment input using these moment input values without thinking about anything. So as we need to give the direction, so if vector no, can get vector forward vector. This is just for testing, so don't worry about it. And put I bind this to y. Okay, so now we can test if our moments are working. We should have some moment when I press W or S. No. Oh, do we have a moment component? We don't. Oh, I forgot about that. So that's why there is no moment. So here, controller pawn, we need to, I'm gonna add a floating moment component. Yes. And your floating moment component, let me forward define that. Right. Copy the header file to the C++. We need to create that too. And one moment. First, create default sub-object using the type floating component. The name floating point. All right, now we have the floating moment component. So let me compile again. Now we can move forward, backward. Okay, so now here this movement is not relative to the character's orientation. That means here if I, well, it is related to the character's orientation because I'm using characters forward. But later on, if we implement a method to rotate the camera without rotating the character, we would run into some problems with this kind of logic. Of course, right now we don't have any rotation input, so we should be fine. But just in case, let's do that also. Yeah. So if we have a controller, then I'll get const rotator. We can get the rotation from controller. Get rotation. It should be simple. That's why I didn't get the suggestion. Okay, now from this I can get the yaw rotation because I only need to consider the yaw rotation of the controller in order to determine forward and right axis relative to the controller's direction that we are looking at on horizontal plane. So F rotator yaw rotation. So here we need to only consider yaw. So rotation dot yaw 0. Right. Now step vector forward. So this is forward relative to the direction that we are looking at. So controller forward. F rotation matrix rotation it axis the axis. So this is the forward. In the same way, I can get the right vector as well using y. Okay. Now here forward will be mapped to that we just calculated, and this right with the x component of the input. Right, now compile again. Forward, right, left, back. So now we can move around in our case. Alright, great. Now we have moments for our pawn in our strategy RTS controller. Okay, so that's all I'm gonna do for today. And thanks for watching. As always, updated project files will be here in the Patreon page. Don't forget to like and subscribe. See you in another episode. Goodbye.